afternoon, and thank you for joining our session. If you've been here last year, Taras and me presented in Lisbon how we brought open networking with cloud management to campus networks. OpenLAN is a community-driven work under the Telecom Infrastructure Project, which includes two sides. It includes the OpenWiFi and the OpenLAN Switching. And today we will focus on OpenLAN Switching. And we will share the progress we've made in the last year in terms of features, new SKUs, and our adoption of SONiC going forward. My name is Gidi Navon. I'm part of the solution group at Marvell Semiconductor. And here with me is Taras Chornyi. He's the director of open networking at PLVISION. PLVISION is a software company specializing in SONiC and open source solutions. So let's kick off things with a short recap of what OpenLAN is. So as I said, it is managed under the Telecom Infrastructure Project. And we like to break it down to three main pillars. The first is the foundation. So we are building on the strong foundation of the OpenWiFi. In the OpenWiFi, the community is providing a full software and firmware for the Wi-Fi access points. And what became clear is that those Wi-Fi access points need to be aggregated by Ethernet switches. And this is where OpenLAN switching came into place. And we have switches ranging from 10 ports to 48 downing ports, from 1 gigabit to 2.5 gigabit, and going to 10 gigabit copper, with, of course, PoE and PoE++ to power those Wi-Fi access points. And the OpenLAN has shipped over 220,000 devices up to now, with a run rate of about 15,000 devices per month, currently mostly the access points. And basically, we have been doubling the number of devices every year since 2021. And the last pillar is the power of of collaborating in the community. Us as a team is not only developing the solution, but also validating it and making it ready for prime time. If we look at the software components, so starting from the zero trust provisioning, ZTP, this is a key to the entire open cloud management. Every device, every OpenLAN device, authenticates itself with the TIP certificate authority and receives back instructions to which cloud managed provider to connect to. And after a secure connection is made to the correct cloud provider, then management can start, configuration of the device, telemetry and events can be sent back, and when needed, the software upgrades. And when we talk about the software or the firmware of the devices, so if we talk about the OpenWiFi, here we provide the entire source code of those Wi-Fi access points. But on the switches, the only part which we provide is a northbound interface from the switch, from the network operating system to the cloud. And we will talk later about the evolution that we see towards using more and more SONiC. Now, the important or unique thing about this project is the cloud management using the cloud SDK. So instead of having the system vendor providing a management system that works only with the network operating system provided by this with this box, now we have companies which are specializing in cloud management and working together with managed service providers, and they can manage any device from the OpenLAN community. And this is a strong proposition. Going back. The only part which is outside the territory of the OpenLAN is what's shown here in brown, which is the business logic. All the things regarding of planning the network, deciding which device to choose, ordering systems, all this business operational stuff, this is kept because this is unique to each managed service provider. building a strong ecosystem is really what made us successful, I believe. And it starts with hardware diversity. Without hardware diversity, we cannot create the competition that is needed to drive costs down. And driving costs down is important for making it a popular solution. And the diversity is also on the silicon side. While I'm from Marvell Semiconductor, we have devices from other switch vendors. In terms of the community work, so I mentioned this is what we're all about, openness. And it always amazes me how competing companies really come together and not only bring high quality devices, but also bring innovation to the solution. And I think this is because we have a common goal in taking business from the closed camp. And as I said, the key part is the cloud management. So we have the managed service providers have the option to keep the devices that is already deployed and change the provider of the cloud management because of this openness. And this is not the case when you're buying something from an OEM. You want to change it, you have to take the gear out. So let's highlight what have we achieved in the last year in the OpenLAN Switching project. I'm not talking about the OpenWiFi. So in the OpenLAN Switching, we started with only 2 SKUs, and now we have a total of 22 hardware SKUs, and I'll show the different SKUs that we have. We now have 4 different ODMs to choose from, and we keep adding features, and most of the work is basically rigorous testing of those features and making sure they can be managed uniformly from the cloud. And we have not only 4 ODMs, but we actually have 5 network operating systems because one of the ODMs is providing both its proprietary NOS and SONiC. And we're proud that now more than half of our solutions are based on SONiC. And we'll talk about the evolution in the coming slides. And I mentioned, apart from Marvell, there are other providers for the silicon. So this slide is showing the different, the 22 hardware SKUs that we have now. So we started in OLS 3.0 with very few SKUs, but now we have switches from 10-port switches to 54-port switches. And when I say 54, it's 48 downlinks and 6 uplinks, which can be 10 gigabit, can be 25 gigabit uplinks. And in OLS 4.0, we added 2 main important things. One is the downlinks towards the access point is not only 1 gigabit, but are also 2.5 gigabit. And we also added an aggregation switch. So now we can build networks with 3 tiers. We have the Wi-Fi access point tier, then we have the first tier Ethernet switches, the access switches, and now we have also an aggregation switch. And this means you can build pretty big networks. And we're not stopping there. In OLS 4.1 that we're working on now, we'll be adding even more M-Gig SKUs, not only 2.5, but also 10 gigabit copper to connect to Wi-Fi 7 access points, which require this extra bandwidth. In terms of features, so we keep adding features, but now in OLS 4.0, I think we have sufficient amount of features to really allow real deployment, and we see deployments already happening. So we added LLDP, we added PoE power negotiations via LLDP, we added multi-chassis lag and ACLs. And I encourage everybody to come back and give us feedback. What do you think is still missing? And we keep adding things. We are finding things that are missing in SCI and SONiC, and we work with the PENS working group on adding them there too. Now, before I hand it over to Taras, I want to show a little bit what we feel the evolution of the network operating systems. So when we talked about that the OpenLAN switching only mandates the northbound interface. You can use any NOS in this community, unlike the Wi-Fi access points in which you have one software and then you have commonality of the features. But in the switching, we have we can have vendor-specific NOS, and by nature, then features behave and act differently. But then we have vendor flavors of SONiC. This is one step towards commonality, because features that are part of the SONiC, the community SONiC, behave the same, but of course each addition is behaving differently. And when I show this evolution, each step is not instead of the previous step, it's in addition. And then we have ODMs that are taking the community SONiC as is and hardening it. But before they harden it, they need to attach the UCentral client, which is this is the agent that talks with the cloud management, to the SONiC before hardening it. And I'm proud to share that these days we are creating what we call the OLS SONiC, in which the community is the one that is taking the UCentral client, integrating it with the community SONiC, and sharing it as an open source. Because hardened SONiC, you need, if there's a problem found, you need to go back to the ODM and ask it to fix it. Here you have full visibility of the source code. Okay, and now I'll hand it over to Taras to say a little bit more about the software architecture of the solution and the SONiC integration. Thank you.
Yes, so it's been a journey for the OpenWiFi, OpenLAN, and as the project on OpenLAN Switching as a sub-project of it, from initial, as Gidi was saying, 2 to 22. But the whole this thing will only be relevant if you understand what is it and how it works. So how the OpenLAN switching works. Basically, nothing new. The things that are working, we shouldn't change it. We should just adopt. So we focused on adopting the OpenWiFi management plane, which was quite successful. And as Gidi was mentioning, hundreds of thousands of devices already deployed in production currently in the world, and extended to also work in the switches. The main concept of this is, as we see here on the picture, we have the same cloud SDK. I will talk a bit about it later. We're using the same OpenLAN certificate authority. We're using the same UCentral protocol. We did extend it to include the networking functionality that are specific for the switches. We are utilizing the same ZTP process for the OpenWiFi. And additionally, what we add is we said, okay, we have now the switch. Let's it use the UZTP, the UCentral, and let's it talk to the same cloud, which basically extends from managing only Wi-Fi networks to managing the whole network. And how it's managed is quite simple. Again, we have the all, let's say, minimal, or I would say full, depends who is asking. You can configure, you can monitor, you can remotely troubleshoot, and the important part, you can also maintain it. Amir was saying about the updating of the different versions of the software on different vendors. The OpenLAN switching does it out of the box. You have the capability to update from the cloud and to manage it through the cloud. So the cloud SDK. The cloud SDK itself, it's quite a topic. It requires a separate discussion. But in a nutshell, it's a completely open source, microservice-based cloud application which allows you to build your own cloud or use it as is. What I mean by this? Cloud SDK provides all necessary components which allows you to monitor, like we see statistics here, we see some interfaces, we see the overall information about the switch itself. To manage, you can see what devices are connected, you can update it, you can deploy, you can do templating. And it also provides a sophisticated northbound APIs. If you may remember the slide from Gidi was showing about the gray one, the business logic, to build your value-added services on top. So out of the box, Cloud SDK is ready to be deployed and used as is. If you want to add your value-added services, you still can. There are not enough place in this domain how you can innovate it. And basically, as I said, it comes with already the interface available with the certificate management included, and it's also basically single Docker Compose. You have the Azure instance, you define your domain, and you have the Cloud SDK up and running. And the next part, in order to connect the switches to this cloud, Gidi was saying, we were defining northbound. There are a number of proprietary or vendor-specific NOSs, and we've defined the northbound. And as the evolution of all of this, we thought, okay, let's do it in SONiC. And if you may remember, the Paul from Celestica was saying, SONiC is microservice architecture, great for extension, you can run your own stuff. That's what we did. In addition to SONiC itself, which is the left part of this diagram, we've added a container, which implements the northbound, which cloud needs. The only part that it's, let's say, does to the SONiC itself, it replaces the SONiC ZTP process, which a lot of guys were talking about, how you deploy your data center, your DHCP stuff, all this, with ZTP process of the OpenLAN Switching project. And basically, what's happening, it implements it to the northbound, to the cloud, a TLS WebSocket communication, which allows bidirectional communication through the single FOFOS report, so it's quite friendly to the enterprise firewalls. And most important part, it's completely well-defined. So you have the public schema, you have the public protocol, which works as you expect, and you have a number of SKUs and devices and even NOSs that supports this and extend this. Why? Why do we do it? Yes? Where we should use it? There are a lot of use cases we can think about, but let's think from different direction. So when we came here this morning and registered to this conference, they gave us the Wi-Fi network credentials. They gave you the name and they gave you the password. So basically this kind of, even here we have a quite a, I don't say big, maybe medium size enterprise Wi-Fi network, which is needed every day, and it has to be configured through OCP today. Next event will be tomorrow, or in a week. You need to reconfigure and change it. And by doing it through the centralized management, definitely makes sense, yes? Additionally, it's not just event halls and public spaces as we have, like even airports, bus stations, train stations, even city centers. It can be used in the industrial sites. What's unique about the OpenWiFi and OpenLAN and OpenLAN switching is it can be either cloud managed through the public cloud, as companies like Gidi was mentioning, network service companies. You can also deploy it locally. So you can use the exactly same technology, but run it locally. So automating your industrial sites where you don't want maybe your data to go to the public cloud, also possible. And another part, it's the MDUs. The university campus or MDUs itself, where you have a lot of users which needs this network right away. It's easy to deploy and easy to manage. And the biggest advantage, you don't need highly skilled technicians. You are packaging your equipment out of the factory with a certificate. It's delivered to the location. You have a technician that are shown, okay, connect 1, 2, 3, 4, and go away. Everything else will be done through the internet, automatically discovered, configured, and then maintained. So, key takeaways. Diversity. As Gidi was saying, 22 SKUs, 4 different vendors, 5 different NOSes. It's only on the switching side. We have, I believe, up to 60 or 80 SKUs from the Wi-Fi part. Same protocol. Maturity. It's not ready to deploy. It's already deployed successfully all over the world. And SONiC-centric. We recognize that SONiC is conquering the world. It's done the DC. Broadcom is saying it's the best one for the AI. And we see it's also the best one for the campus networking and industrial. So it's well fitted. What to do with it? First of all, if you see that what we have now is not enough, please reach out and let us know. We are missing this use case. We don't know your networks. The challenge with these kind of networks is it's always like Wild West. you have this in this location like this, you have the network in the another location like that. It's not greenfield as in typical data center or AI cluster when everything is managed and well-defined. Additionally, there is an interesting point on the how heavy SONiC is. It's a separate topic. I will not mention to it, but if you know how to help us and make it even more optimized, feel free. And join us. The documentation, the repos, the community is all there. Try it and give us the feedback. Thank you.
Any questions?
So I would like to return a question you asked Amir a while back. You have several chip vendors, you have several or multiple platform vendors. How do you deal with differences in configuration of those different sorts of platforms?
We don't have it. What I mean by this, it's a community, but it's tough community. There is a well-defined schema and well-defined how it should work. If it doesn't work, you are not supported. This feature is not supported on your platform. You must adhere to the northbound. It's a bit a limiting factor, but this is what allows us to simplify overall solution. So basically, there is a separate community-backed lab which has the devices which are extensively tested by the community member that these use cases, this configuration behaves exactly as we want to see it for this specific scenario.
I want to add, we now are thinking about creating a certification procedure in which you can get a badge of OpenLAN certified. We're now defining again the minimal the feature set and the testing procedure, and then people can say I am OpenLAN certified. But this is now work in progress.